All right, good morning, afternoon, happy Thursday. Glad you all made it. All right. So here's the plan for today. I'm going to try to finish this lesson, and I either have or I'm going to change the due date for the assignment. The assignment's going to be due on Tuesday, 1/19. But that doesn't mean wait to the last minute to do it. That's just giving you time to do it. So this was the second problem that I started. And you guys have this much, right, of the second problem? Yes, hopefully.
We got up to like the coordinates. That's what I left off on.
Yeah, so you got this much, right?
Yes.
Yeah, we have the coordinates written down already.
Okay, so I thought that I had given you a paper that I wrote, but I actually put the paper today, the whole paper, in Google Classroom. And I hope I have time to show you, but what it is I'm showing you the same problem done with the two different forms. So in other words, I'm showing a problem in the two different forms. I'm showing another problem in the two different forms so that you can see the advantages of form number one and form number two. Because guess what? Form number one doesn't work great with graphing rational equations. So lots of times you want it in form two. So if you can write it in form two for these guys, for form two might be easier. Okay, so I'll show you later. All right, hopefully. So here we go. All right, so this is a horizontal, this is the form two. This is a horizontal compression by 1/2, left 3, down 1. So this horizontal compression means multiply the x by 1/2. Multiply the x by 1/2 would be 1/2 of 2, which is 1. Multiply the x by 1/2. Multiply the x by 1/2, which would be 1/2 of -2, which is -1. And the y stay the same. By the way, one of my Algebra 2 students said, Miss Birch, when I go to the online problems, I'm getting geometry. I'm like, no way. So I had her log off, log on, do this, do that, do this, do that. And guess what? For some reason, she was not connected to Algebra 2 anymore. So I need you all today, make a note right now. You need to check your online My HRW. And if you are connected to geometry, you need to let me know so I can fix it. Now, I did check with 4 random students in different periods, and they all said they were okay. But I'm just letting you know that I need you to check My HRW and make sure you're getting the Algebra 2 online problems and not geometry. I did talk with HMH this morning at 4 o'clock because they're open at 7 Eastern time. So I did get that student's problem straightened out, and I'm able to straighten out. If you have that issue, let me know. Okay, so left 3, so this is where it gets crazy because you have to take, let me erase this now. You have to take 1/2 minus 3, and you have to get a common denominator, which would be 1/2 minus 6/2, which would be -5/2. Subtract 3 would be -2. Subtract 3 on this one would be -4. But this one is going to be what? -1/2 minus 3. Get a common denominator, which would be -1/2 minus 6/2, which is a -7/2. So it's really testing your basic math skills. So this y value would be 1/2, -1, -1/2. Okay, can I erase this over here now? You would do this off to the side of your paper on the left.
Yeah.
Yeah. All right, now we're going down 1. So the x stays the same, -5/2, -2, -7/2, -4. And when you go down 1 would be a 0, and down 1 here is a -2. So 1/2 minus 1 would be -1/2. And -1/2 minus 1 would be -3/2. Glad we got through that. Okay, now what we want to do is we want to graph the new asymptotes. Now remember what we said yesterday. The vertical asymptote is h, and the horizontal asymptote ends up being k. So what is the new vertical asymptote? X equals what?
-3.
And the new horizontal asymptote would be y equals,
-1.
yeah. So I should write these down here. So you want to graph those first because those serve as a really good guide for all of these crazy points. So x equals -3 would be here. And y equals -1 would be there. Okay, now the points of the graph, this would be -2.5. So you go left 2.5, 0. And you go left 2, down 1/2. So you're going to run this part of the boomerang up along the asymptote and that part around that asymptote. Don't hit the asymptote. Don't touch it. Okay, this would be -3.5, down 2. And this would be left 4, down 1.5. So you run this along that asymptote and you run that along that asymptote without hitting it. So now we're ready for the domain in the different notations. So the domain would be forever left and right except at -3. So it would be x is less than -3 or x is greater than -3 in inequality notation. For set notation, it would be x such that it's everything but -3. And for interval notation, it would be -∞ up to -3 open or -3 to infinity. So that's the domain. I'll just write the range up here because I don't have any room. So the range, remember, is up and down. So the range is everything but -1. So this would be y is less than -1 or y is greater than -1 in inequality notation. In set notation, it would be y such that it's everything but -1. And in interval notation, it would be -∞ up to -1 or 1 up to infinity. Okay, now here's the question. These problems were easy because they're in the form. What if they're not in the form? So what happens if they're not in one of the forms?
You have to make it into the form.
Yep. So let's look at that. You're never going to believe what we're going to do either. Okay, do you guys believe that the form has a 1 or a constant on the top and an x on the bottom? Like we haven't seen like an x squared and x or an x over x. Those do exist, but those are more complicated rational equations. We're not doing those. So we're just focused on simple rational equations where you have a 1 or a number over an x. Now you're not going to get confused about this, right? Look at this. Isn't this the function with b being 1? And isn't this the function in the second form with a being 1?
Yeah.
And they want you to do all that stuff we just did. Okay, here's the problem. So hold on a second. We don't have a form with an x on the top. So guess what you're going to do? You're going to do division. Watch this. If you take 3x minus 4 and you divide by x minus 1, you get 3. Off to the side, you have 3 times x minus 1. So this turns out to be 3x minus 3. And we get a remainder of negative 1. Well, how does that help us? Well, check this out. Wouldn't this be the quotient plus the remainder over the divisor? And couldn't this be written as this? Ta-da! Crazy, huh?
Yeah.
So when you have this type of problem with an x on the top, you're gonna do the division and write the quotient plus the remainder over the divisor and actually get the form. And isn't this form number 1? So who would have thought that we would be using long division to get the form that we want? So state the transformation, please. I'll write it down here. What's the transformation?
1 to the right, or yeah, right 1, and then would it be a reflection on the x-axis?
Yeah,
And then up 3.
good. That's exactly right. All right, so, okay, can I move the screen up now? Do you guys all have this all written down?
Yeah.
So our points are right one, up one, right two, up a half, left one, down one, left two, down a half. So here we go. We're going to go right one, right one, right one, right one. We're going to reflect X, which means negate the Y. Right? Look at my arm. Reflect X means negate the Y. That's a vertical movement, right? So negate the Y, negate the Y, negate the Y, negate the Y. And then we're going up 3. So up 3 would be a 2 and up 3 would be a 4, but up 3 here would be 3 minus, or sorry, negative a half plus 3. You need a common denominator. So wouldn't that be 6 minus 1 is 5 halves? And positive 1 half plus 3, get a common denominator, would be 7 halves. So once again, we're going to do our asymptotes first. So what are our asymptotes?
X would be 1 and Y would be 3.
Yeah. And I knew I was going to write them there. I want to write them down here. Where are these going? What problem am I doing? I think we're okay there. Okay. So we have, I'll just write more here. X equals 1, Y equals 3. Okay. So we have a vertical asymptote at X equals 1, and we have a horizontal asymptote at Y equals 3. Okay, so here we go. So we're going to go right 2, up 2. We're going to go right 3, up 2.5. And we're going to draw our graph along the asymptotes. And then we're going to go 0, up 4. And we're going to go left 1, up 3.5. And we're going to draw this along that asymptote and this one along that asymptote. And notice they're in different quadrants because we did a reflection over X. So instead of it looking like the previous problems, this was reflected over X. They were reflected, but they were also shifted up 3. Okay, so let's go with the domain. The domain would be everything but 1. So it would be all X less than 1 or all X greater than 1. The set notation would be X such that it's everything but 1. And the interval notation would be negative infinity up to 1 or 1 to infinity. The range would be everything but 3. So it would be Y less than 3 or Y greater than 3. In set notation, it would be Y such that Y is everything but 3. And the interval notation would be down, up to 3, open, or 3, up, forever. Okay, I'm gonna do one more of these. Do you guys want to ask me any questions about this one? Okay, do you guys, can I erase this part over here?
Yeah, can you move the camera more to the second board, please?
All right. So here's another one of those fabulous problems that is not in the form. So I'm going to use long division to figure this out and put it in the form. So here we go. So this is going to be 4x minus 7 in and out divided by negative 2x plus 4. So this times what is that would be a negative 2. Off to the side of the paper, we have negative 2 times negative 2x plus 4, which would be 4x minus 8. So we're going to subtract off 4x minus 8, and we get 7 plus 8. Negative 7 plus 8 is 1. So what we have here, I need you to pay close attention to what I'm doing, okay? What we have here is we have negative, not green. We have negative 2 plus the remainder over the divisor. Now listen up. This right here is form number 1. But later on, I'm going to show you, we love form number 1 for the quadratic. We love form number 1 for the cubic. We love form number 1 for the absolute value. We like form number 1, but guess what? If you say that the vertical asymptote is 4, you're going to get the wrong graph. The vertical asymptote is actually, it's negative 1/2 of 4. So it's more complicated. So let me just show you this, okay? I'm going to write this in form 2, and I'm going to show you later why the rational equations are better in form 2. But watch. So can I write this like this? Let me slow down. If I move that negative up, wouldn't this be a positive 2x minus 4? So if I move a negative up, doesn't everybody flip? Isn't this equivalent to that? Yes, no?
Yeah.
Okay. So if I write, can I write this like this? Can I take out a 2? And so this now is form 2. And what I did was I did a GCF on the bottom to put it in form 2. And look up here. This is the vertical asymptote. It's x equals 2. And the horizontal asymptote is y equals negative 2. I'm going to show you in the paper I wrote in a minute. Okay, so just bear with me. We did the problem. I got form 1. I know from experience that form 1 isn't great because that's not the vertical asymptote. You actually have to multiply that 4 by a negative 1/2. So you have to compensate with it over here. So negative 1/2 of 4 is negative 2. So basically what I did is I manipulated the equation to put it in form 2 without messing it up. So now state the transformation. It would be what?
It would be 2, right 2.
Wait a minute, that's the wrong order because you have it in form 2. What's the order for form 2? It would be a horizontal compression by 1/2.
Left 2 and down 2.
Wait a minute, reflect X.
Mm-hmm.
Right 2, down 2. Right? It's a messy problem. It's a lot of steps. All right, here we go with the points. So we have 1, 1, right 2, up 1/2, left 1, down 1, left 2, down 1/2. Now listen to me. If you want to leave it in form 1, go ahead, but you can't. You got to make sure you fix the asymptote because the asymptote is not -4. The vertical one. It messes up the vertical asymptote. All right, so here we go. Horizontally compressed by 1/2. 1/2 of 2 would be 1. 1/2 would be -1/2. And half of that would be -1. Reflect X means negate the Y. So negate the Y, negate the Y, negate the Y makes that positive, negate the Y makes that positive. Right 2. So right 2, I'm just going to make it 2.5. Right 2 would make that 3. Right 2. So wouldn't that be 3/2? And right 2 would make that what, a 1? So this would be -1, -1/2, 1, 1/2. So here we go, down 2. Let me put the X's here, 2.5, 3, 3/2, 1. So down 2 would make that -3. Down 2 would make that -1. Now, -1/2 down 2, you need a common denominator. So that would be negative, what, 5/2? And down 2, get a common denominator would make that -4, was that -3/2? What a mess. Luckily, all your problems aren't
Can
like
you
this.
a little bit?
All right, here we go. So the vertical asymptote is right here in form 2. It's X equals 2. The horizontal asymptote is Y equals -2. Let's graph the points. the points would be right 2.5, down 3, and right 3, down 2.5. This would be right 1.5, down 1. And that would be right 1, down 1.5. So this is going like that, that's going up like that, and there's your answer. All right, so do you mind if I don't do the domain? Do you guys understand the domain? The domain is everything but 2, and the range is everything but -2. Is it okay if I just skip that?
Yeah, but do we
Yes.
still write it?
Huh?
Yes, but do we still write it?
In your assignment, they're going to ask for it. So in your assignment, yes.
Okay.
Does anybody want me to do it? Anybody want me to write the domain and range? I've done it on a bunch of problems, so I was just going to skip it. Okay, we're done with this now. So I'm going to get into now writing. We're going to look at a graph and write equations now. Ready? So I'm going to do 2 examples and I'll be done. Okay, this is objective 4. And this is the 4th part of your assignment, writing simple rational functions. So they're going to give you the form and they're going to say, okay, this is it, guys. They want you to write an equation in that form. That happens to be form number 1. And by the way, B is 1. So just like we've done before, you're going to find A, B, H, and K.
Miss Birch, can you move your camera a little bit, please? Thank you.
All right, here's the graph. So in looking, they're going to give you the graph. They give you an asymptote at x equals 3. They give you an asymptote at y equals 4. And they give you points. One point is at 4, 6. And the graph looks like this. And the other point is at right 2, up 2. And the graph looks like this. Okay, does everybody see what I'm saying? They're giving you a vertical and horizontal asymptotes, and they're giving you a couple points on the graph. All right, so help me out here. What's A? Who knows? What's B? What's H? Well, isn't H the vertical asymptote? So what's H?
2.
-3 or 3.
H?
Well,
H?
3.
And what's K? K is the horizontal asymptote.
4.
Right. So now I'm going to pick a point and I'm going to use, you can use any one. You want to use 2, 2 or 4, 6? Let's use 2, 2. All right, so we're going to take g of x is equal to a times 1 over x is 2 minus 3 plus 4. So remember, this is y, and our y happens to be a 2 also. So this would be a times 1 over -1 plus 4. So this would be 2 is equal to -1a plus 4. So this would be -a equals -2. So doesn't a equal 2? Yeah?
Yeah.
You guys okay? All right, so here we go. So the equation then would be g of x is equal to a, which is 2, times 1 over x minus h plus k. And if you want to put that in the calculator and define it the way they graphed it, you should come up with that graph. So it's just like what we did before. This part's just more complicated. Do you understand what I'm doing here? I'm saying that this is 1 over -1, which is this -1. I put the negative in front of the a, and then I solve for a. Okay, you want me to do one more with the b missing?
Yeah.
Can I erase this?
Yeah.
Did any of you log on to my HRW and get geometry instead of algebra 2?
No, I didn't.
Isn't
Usually
that weird?
there's a
Don't you-
tab where you can press a grade level. Like last semester, I was able to do like Algebra 1 if I wanted to, but there's a tab and you choose which book you like want to do.
Oh, really? Because she didn't have that option. So she actually wasn't connected to Algebra 2 at all. But thanks for telling me because,
But yeah,
huh?
I'm not sure like why she got that, but usually I've been able, because when I log on, it automatically takes me to like Algebra 1. But there's
Really?
a tab,
Okay.
yeah, and you just tap it and then you just press Algebra 2 and it takes you there.
Oh, okay. Because she wasn't even physically attached to it at all. She wasn't attached like you were. Okay, look at this. Here's another form, and this happens to be form number 2. And we want to find A, B, H, and K in writing an equation. Let me give you the graph. All right, so in this graph, you have a horizontal asymptote at y equals -1. You have a vertical asymptote at x equals -3. And they're giving you a point at left 1 down 2. And this graph goes along the asymptotes like that. And then they're giving you a point at left 5, 0. And this one's going along the asymptotes like that. So it looks like there's some kind of reflection. Okay, so here we go. So what's A, you guys?
1,
What's B?
we don't know.
Okay, what's H? Well, H responds to the vertical asymptote, and the vertical asymptote is x is equal to -3, right? So that means that H is equal to -3, correct?
Yeah.
And K refers to the horizontal asymptote. So that means K is equal to -1. Is everybody cool with that? Yes, no?
Yeah.
Yeah.
Okay, so here we go. So which point do you like? I need to mark the points. Okay, hold on. So this point was left 5, 0, and this point was left 1, down 2. Which one do you like? I don't know. Honestly, I don't know if I like all those negatives. And we might be better with the left 5, 0. In my notes, I have the left 1, down 2. It's not nice. So we have G, this is X and Y. So we have G of -5 is equal to 1 over B times -5 minus a -3, lots of negatives. Maybe this is worse. Minus 1. Yeah. So G of -5 would be 0. So we have 1 over B times -5 plus 3 is a -2 minus 1. So this ends up being, okay, everybody look up here, please. This ends up being -2 over B, right? So can I just move the negative up?
Yeah.
And remember what I told you yesterday about 1 over a fraction? Do you guys remember what I said?
Did you just flip it?
Yeah, it's the reciprocal. So this would be 0 is equal to, there was actually no reason to move the negative, so I'll just leave the negative down here. So the reciprocal would be -B over 2 minus 1. Just the reciprocal. If you don't believe me, watch. 1 divided by -2 over B is 1 times the reciprocal, which would be -B over 2. Okay? So now we have 0 is equal to, no, wait a minute. We can add 1 to both sides, right? Add 1 to both sides.
Yeah.
So it'd be 1 is equal to -B over 2, and then we can multiply both sides by 2. So -B is equal to 2, which means B is equal to -2. So our function then is g of x equals 1 divided by -1/2, because that's 1 over b is -2, right?
Yeah.
Times x minus h would be x minus a -3.
Would it be plus?
1. Yeah, I got to write it one more time.
Okay.
So it's going to be g of x is equal to 1 in the form that they want, -1/2 times x plus 3, and then minus 1. And that is the correct answer. So. Okay, anybody want to ask me any questions about any of these steps? Okay, I want to share my screen with you, and I want, when I first started teaching this stuff, see, I didn't learn math this way. So can you imagine when I started teaching, I'm like, what the heck is this stuff? And what is really going, I didn't learn it this way. So I was really studying it because I didn't want my students to, okay, this will work this time, this won't work here, this won't work, this won't. I want to make sure that I knew what was going on. So I wrote this paper. Okay, so I want to share this. I thought I shared it with you, but I didn't. So I want to share it with you now. I put it in your classroom. So it's under materials. It's right here. So let me show you what I wrote first of all. In many problems, a function can be written in one of two forms, form 1 or form 2. In order to get the correct graph using transformations, you must follow the specific order associated to the form shown or created for a particular problem. Depending on the problem, there are advantages to one form over the other. This document was written to show various examples of the same problem written in form 1 and form 2. And because the graphs are shown on the same page, it's easy to see the advantages of using one form over the other for a particular problem. So the first page looks like this. So basically what I'm showing is I'm showing the quadratic in form 1 and quadratic in form 2. Square root in form 1, square root in form 2. Rational, simple rational in form 1, simple rational in form 2. And these are the proper orders. For form 1, this is the order. For form 2, that is the order. Now notice what I wrote here. I said form 1 is not good for rational functions. Horizontal stretches or compressions force vertical asymptotes to change. So let me just show you. So in this problem right here, these are more complicated square roots. So this is the problem in form 1, and this is the same exact problem in form 2. Now see how form 2, because I did a GCF, see how it's easier? See how the point transformation is easier? Because I chose to write it in form 2 by doing a GCF. Can you guys see by the work that in this particular, yeah. Okay, so let me go down. So here's another square root. Now, to me, form 2 looks harder. So if you look at the work, multiplying out, actually, it seemed to be easier in this particular problem. Okay, here's square root again. Not much of a difference in the work, but once again, I did a GCF and wrote it in form 2. So this is form 1. I wrote it in form 2. Here's another one. Kind of the same. Okay, there's the quadratic. Notice that form 1 is less steps, or I'm sorry, this one was less steps. That was form 2. I took out a negative. Don't worry about that one. Here's the quadratic again with a -2 factored out. But here's what I wanted you to see. Actually, I want it, yeah. So this is form 1. This is the same problem. If you write it as 1/2 times x plus 2, that's equivalent. See, if you distribute this, right, you get 1/2 of x plus 1. Well, notice that in this problem, the vertical asymptote is x is equal to -2, but on this one, it looks like the vertical asymptote would be -1, and it's not. So the vertical asymptote is actually left. See, if you multiply by 2, you can get it. So it'd be left 2. It's not left 1, it's left 2, the asymptote. The transformation is still left 1, but the asymptote is at x equals -2, not -1. And in this last problem, once again, if you do a GCF and you write it in form 2, the vertical asymptote is at x equals -2. It's not at x equals -4. So what am I saying? If we were all learning a new video game, we're not going to sit and read the user guide that's that thick. That's not how you learn anything on the computer. Like, you don't sit and read through the user manual from beginning to end. You just mess with it. You mess with it and mess with it and mess with it. Well, guess what? With this particular thing, you're going to have to mess with it to convince yourself what's going on. Okay, so I wrote this document for you to refer to, but you're going to have to figure out what's best for you. All right, so what we're going to do right now is we're going to go into the Math Wizard teams. They are new teams, and you are going to introduce yourself and say who your hero is and why. So you're going to introduce yourself and state who your hero is and why. And after that, you can either work on the assignment with your team, or you can get things cleared up from my notes with your team. I don't care what you do with your team. Also, on the assignment, I also provided this sheet, so you can work on this sheet if you want with your team. The only thing I ask is that you introduce yourself, state your hero and why, and you're going to work on something collaboratively. You are not allowed to work on your own. Okay? All right, so I'm going to be taking attendance in the Math Wizard teams. We are not going to report back today, but I'll see you in your Math Wizard teams. Okay? All right, I'll see you in your teams.